Can we pretend that airplanes in the night sky like shooting stars? I could really use a wish right now, wish right now, wish right now. Can we pretend that airplanes in the night sky?
Daniel Bernoulli was born February 8, 1700 in Groningen in the Netherlands. His father was John Bernoulli, another famed mathematician. Daniel went to St. Petersburg in 1724 as professor of mathematics, but was unhappy there, and a temporary illness in 1733 gave him an excuse for leaving. He returned to the University of Basel, where he successfully held the chairs of medicine, metaphysics, and natural physiology until his death. This principle states that for an inviscid flow, an increase in the speed of the fluid occurs simultaneously with a decrease in pressure or decrease in the fluid's potential energy. More simply explained, the faster the molecules within a fluid move, the less pressure they exert on the object around them. Now let's take a look at the equation that can be used to show this principle. At first glance, this could look a little complicated, so let's take each variable and break them down for you. V is equal to the fluid's velocity, G equals the acceleration of gravity, Z equals the height or elevation of the point in the fluid, the lowercase p is equal to pressure, the capital P is equal to fluid's density, and C is equal to the constant. You may not recognize it, but you can see Bernoulli's principle around you everywhere. Have you ever been to one of these before? You may not recognize it at first, but it's actually an airport, so in our lifetime, most of us have been one, which means you've probably been on one of these before. An airplane is a great example of Bernoulli's principle. It's curved along the top, so when the air passes over the wing, it divides. The curve forces the air on top to travel a greater distance than the air on the bottom. When the air hits the front of the wing, the rate of flow at the top increases to compensate for the distance it has to travel than the air below the wing. This lifts the plane up in the air, allowing it to fly. If you didn't understand Bernoulli's principle with the airplane wing, let's try it again, and this time we'll use a bird's wing as an example. Again, it's curved along the top, so that when air passes over the wing and its feathers, it divides. The curve forces the air on top to travel a greater distance than the air on the bottom. When in flight, the air hits the front of the wing. The rate of the flow at the top increases to compensate for the greater distance it has to travel than the air below the wing. How many of you guys put cologne or perfume on this morning? Believe it or not, Bernoulli's principle can also be found in a perfume bottle. But this way is a little more complicated. The air inside the bottle is moving slowly and, according to Bernoulli's principle, has a high pressure and applies a strong downward force to the perfume itself. Through a connection of tubes, the pressure towards the top of the bottle is reduced, and the perfume flows upward along the tubes from a place of high pressure. Then the squeeze pump helps eject it from the spray nozzle. Before we even started the video, you might have been confused with Bernoulli's principle, or, like most, may have never heard it at all. Through this video, I hoped you realized how many examples are around you of Bernoulli's principle and to get a little bit of an understanding of what it really is.